Good morning to all. In today's class, we will discuss synchronizing threads. Last class, I explained the concept with one program on synchronization. Synchronization is very, very important in multi-threading. Okay, in today's class also, we will discuss the concept synchronization. Okay, so here we will see this one, the concept of synchronization. Synchronization in Java is the capability to control the access of multiple threads, okay, to a shared resource. So Java synchronization is better option where we want to allow only one thread to access the shared resource. This is very, very important. So using synchronization, only one thread can access. Okay, only one thread can access the shared resource. Okay, next, synchronized is the modifier, already explained, applicable only for methods and blocks, means we can write only synchronized methods and synchronized blocks. We can't use synchronized keyword for variables and classes. There are no synchronized classes and synchronized variables. That's why we have to remember that synchronized is a keyword which will be used only for methods and blocks. Okay, next. So the advantages of synchronization are, okay, it is used to prevent thread interference and to prevent data consistency problem. Okay, so these are the two advantages of using synchronization in multi-threading. Okay, the drawback is increasing the waiting time. Okay, means which affects the performance of the system. So if there is no specific requirement, don't use synchronized keyword. Okay, next. So coming to the synchronization, here we have two types of synchronization techniques. They are mutually exclusive and inter-thread communication. These two are very, very important. Okay, so what are the two types of synchronization techniques? They are mutually exclusive and inter-thread communication. So coming to the mutually exclusive, in today's class we will complete mutually exclusive. Remember these two, mutually exclusive and inter-thread communication. So these two are the synchronization techniques. So mutually exclusive and inter-thread communication. So now in today's class we will complete in depth about this mutually exclusive. So coming to the mutually exclusive helps keep threads from interfering with one another while sharing the data. Okay, next, this can be done by three ways in Java. Okay, that is synchronized method. You know mutually exclusive term in probability and statistics, no? I think you are ECE students, no, you have PTSP subject. Probability theory and stochastic process. Maybe you know this word, mutually exclusive. When two events are said to be mutually exclusive, you know, no? Like that, here also two threads. Between two or more threads, we will apply mutually exclusive. Or disjoint events, means intersection is empty. Okay, then we can say mutually exclusive. So here, what are the mutually exclusive techniques again? Again, under mutually exclusive, we have three techniques. Means three types of programs we can write with mutually exclusive. They are synchronized method, synchronized block, static synchronization. Okay, so at least try to write one program on each of these three types. Okay, under mutually exclusive, we have synchronized method, synchronized block, and static synchronization. Now I will explain one program on each of these three types. Now what is the first one? Synchronized method. So already last class I explained. So you can read this theory. If a method or block declared as synchronized, then at a time only one thread is allowed to execute that specific method or block on the given object. These two statements are very, very important. Okay. So here you can understand these three paras. Now I will explain. Okay, one program on synchronized method. Understand this program. Last class also I discussed one program on synchronized method. This is the second program. Okay, try to practice both the programs. Last class I have taken one display class, and the class name is display in the last class program, and inside that the method name I have taken as synchronized wish method. Okay, so here there the class name is display and the method name is wish. So wish method is declared as with synchronized keyword. That's why that method is synchronized method. Okay. Now I will explain. This is second program on synchronized method. Okay. If you declare any method as synchronized, it is known as synchronized method. Okay. Synchronized method is used to lock an object for any shared resource. Here lock already explained. When you use synchronized method or synchronized block, that concept is, okay, we have to get the lock of that particular object. So that's why here I will explain more clearly. Here in mutually exclusive, we have three types: synchronized method, synchronized block, and static synchronization. So for synchronized method and synchronized block, we have to discuss object level lock. Okay, so for these two concepts, okay, these two concepts are for object level lock. Okay, but if you take static synchronization, this is class level lock. Okay, in these two concepts, the thread requires the lock of that particular object. That's why these two concepts are under object level lock. But if you take static synchronization, this is class level lock. You know static variables in Java. In any class we can write instance variables and static variables. Static variables means what? Static variables are also called class variables now. So the scope of the static variables is throughout the class now. Okay, like that. Instance variables means, see, try to understand the difference between instance variables and static variables. Instance variable scope is only in that particular object, because as part of object, instance variables are stored. That's why the scope of the instance variables are only for that particular object. That's why instance variables are called object level variables. If you take static variables are called class level variables. Means for the scope of the static variables is throughout the class. Okay, if you understand static variables and instance variables and the difference between instance variables and static variables, then you can understand these three concepts more clearly. So instance variables are called object level variables, static variables are called class level variables. Like that, synchronized method and synchronized. So okay, or to write the programs on synchronized method and synchronized block, we need lock of the object. So that's why these two are like instance variables. Synchronized method and synchronized block are like instance variables. So instance variables are object level variables. Like that, compare this. Okay, like that. So for synchronized method and for synchronized block, we need only the lock of the object. That's why these two are object level. Means here in these two concepts we need lock of the object. But if you take static synchronization, here we need the lock of the class. Means class, okay, lock of the entire class we need. You know, this concept is like static variables, because here also static is there, no? So static variables means class level variables, no? Like that, static synchronization means we need the lock of the class. So for these two concepts we need the lock of the object, and for the last third concept we need the lock of the class. That's why try to correlate with these two, with instance variables, and this is with static variables. So for these two concepts, again I am repeating, remember carefully, what is the difference between these three types? For the first two types, that is whether synchronized method or synchronized block, we need the lock of the object. But whereas for static synchronization, we need the lock of the class. Okay, when we discuss the programs, I will explain more clearly. But now understand the for applying these two concepts, we need object level lock, and for applying the third concept, that is static synchronization, we need class level lock. Means lock of the class here. For these two concepts, lock of the object. Okay. Now we will see one program on synchronized method. So if you declare any method as synchronized, then that method is called synchronized method, and synchronized method is used to lock an object. See here, already explained, no? Synchronized method and synchronized block. Okay, for both these two concepts, we need the lock of an object. Means we are locking the object. Okay, you know the once you define the class for student, we will declare any number of objects for the class, no? So when you take student class object, if you want to apply any synchronized method inside the student class, then to execute the synchronized method, we need the object level lock. Means the lock of the object. Means this object is locked. Once the synchronized method is trying to access this, or to execute the synchronized method inside that object. So when the thread is accessing the synchronized method of this object, okay, no other threads can access the synchronized method of the same class or of the same object. So if a thread is accessing synchronized method of an object, then the other threads have to wait till this thread completes the execution of this synchronized method. And one more point is, the remaining threads cannot access any other synchronized method of the same object, but the other threads can only access the non-synchronized methods of the same object. Last class I explained, inside one object of a class, we can have any number of synchronized methods and also any number of non-synchronized methods. But once a thread got the lock of this object, then what does it mean is, so these all the synchronized methods are locked. Okay, object lock is nothing but we are locking all the synchronized methods of that object. So what does it mean? So all the synchronized methods are locked once the object is locked. What does it mean? What does it mean? If one thread is accessing the synchronized method, okay, of this object, then the remaining threads cannot access not only that synchronized method, and they cannot also access the remaining synchronized methods of the object, but they can access the non-synchronized methods of that object. That is the concept. Okay. Now if you understand this concept, here we are taking only one object. See, follow carefully. Only one object. We are taking only one object. Inside that one object means class is first, no? So whenever you want to create an object, compulsory first you must define the class. For that class only we can create object. So inside the class, I will write both synchronized methods and non-synchronized methods. So that's why inside the object, we have both synchronized methods as well as non-synchronized methods. That is the concept. So inside the object, we can have both synchronized methods and non-synchronized methods. If one thread is accessing one synchronized method of this object, means the remaining threads cannot access any one of the synchronized methods of that object, but they can access any non-synchronized method of that object. So that is the concept of synchronization. Okay. When we say what is the difference between synchronized method and non-synchronized method is, if a method which is declared with a synchronized keyword is called synchronized method, a method which is not declared with a synchronized keyword is non-synchronized method. So concept is, now we are discussing synchronized methods. Means an object, in any object we can have both synchronized methods and non-synchronized methods. Okay. Now I will explain the second program on synchronized method, because last class I already explained one program on synchronized method. Now try to understand this program, because in all these three concepts I am using in all these three types, that is synchronized method, synchronized block and static synchronization. I am taking the same method, that is print table. So with respect to this print table method, okay, so with respect to this print table method, I will explain these three concepts, that is synchronized method, synchronized block and static synchronization. That's why I have taken only one method, that is print table. Okay, using that print table method, I will show you, I will explain these three concepts. In this case, you can understand the difference between these three concepts more clearly. Okay, now first I will explain the program on synchronized method. Okay. Now here synchronized method demonstration means program on synchronized method. See here. Here I will read out again one of these two lines. If you declare any method as synchronized, then that method is called synchronized method. And synchronized method is used to lock an object. We are locking the object, because synchronized method and synchronized block, okay, are applying only on object level lock. Okay, for any shared resource. Shared resource means it can be method, okay, or block. Next, when a thread invokes a synchronized method, see, when a thread invokes a synchronized method, it automatically acquires the lock. This is very, very important. No need to do anything manually. Okay, so internal mechanism is there. That's why here once you declare a method as synchronized, then that method is called synchronized method. When a thread is invoking a synchronized method, it automatically acquires the lock for that object. Because inside one object we have synchronized methods and non-synchronized methods. No? So when a thread is invoking a synchronized method of this object, then it automatically acquires the lock for that object and releases it when the thread completes its task. So whenever this thread is accessing the synchronized method of this object, so we are getting this, then that thread automatically get the lock of this object. And when it releases that lock on this object is when this thread completes its execution of this synchronized method. So after completely executing the synchronized method by this thread, then only it will release the lock. That's why here it automatically, again I am reading, these two statements are very, very important. When a thread invokes a synchronized method of an object, then it automatically acquires the lock for that object automatically and releases it when that thread completes its task. Means when the thread completes the execution of the synchronized method completely, remember. So when the thread completely executing the synchronized method, then only it will release the lock on that object. This is not method level lock, object level lock. Object level lock means inside object we have both synchronized methods as well as non-synchronized methods. Because object level lock is nothing but we are locking all the synchronized methods. Remember this point. Okay, we are locking all the synchronized methods of that object. That is nothing but object lock. So if a thread is executing one synchronized method of that object, it automatically acquires the lock of this entire object. What does it mean? It acquires the lock of this entire object means all the synchronized methods are locked. No? That's why when the thread is accessing one synchronized method, then the other threads cannot access the synchronized methods or the other synchronized methods also. They have to wait until the thread completes this synchronized method execution. Once the thread completes the execution of this synchronized method, then it releases the lock. Means it releases the object lock. Okay, so it automatically acquires the lock for that object and it releases the lock when the thread completes its execution. That is, when the thread completes its execution of this static, not static, synchronized method. That is here. So when it acquires the lock and when it releases the lock, here you can understand more clearly. Here it is called object lock. So in synchronized method and synchronized block, we use object level lock. Whereas in static synchronization, we use class level lock or class lock. Okay. Now we can, after completion of these three programs, we can see what is the difference between object level lock and class level lock. Okay. This is for synchronized method. We use lock on the object. Okay. Object. Now I will explain the program on synchronized method. Now class table. Here the name of the class is table. In the last class program, I have taken this as display and I have taken the synchronized method as wish. Same, if you understand the last class program, same syntax I am using, but only I have changed the class name and table name, this method name. Okay, last class name is display, last class program, class name is display and method name is wish. Okay, here in the second program on synchronized method, I am using class name as table and the method name as print table. Okay, now same concept. See, here I will explain. Class table. Okay, so this is the class name. Inside that I have taken one method name, that is print table, and name and return type is void, and it is taking one parameter which is integer parameter. This is the print table. Okay, this is the print table syntax. Return type is void and it is taking one integer parameter. Now I am taking this method as synchronized method. Then what we have to do? If you want to take this method as synchronized method, so declare this print table method as or with synchronized keyword. If you declare this print table method with synchronized keyword, then I can say this method is called synchronized method. Here inside the class table, I have taken only one synchronized method, that is print table method. Like that, we can write any number of synchronized methods and any number of non-synchronized methods in one class. Okay, but here we are trying to understand the concept of synchronized method now. That's why I have written inside the class table, I have written only one synchronized method. Like that, you can write any number of synchronized methods and any number of non-synchronized methods inside the class table. Okay, now we can say print table is a synchronized method. After that, so here I am taking one for loop for int I is equal to 1, I less than equal to 5, a plus plus system dot out dot println n into I. So inside the for loop I am printing, what is this one? N into I. I will show you. N into I is what, I will explain later. Now inside the synchronized print table method, I am taking one for loop and inside that for loop I am printing only n into I. Okay, after that try catch. You know sleep method already explained in thread class. No? It will sleep for some time, after that it will execute. Okay. Next, so inside the synchronized print table method, I have taken only one for loop. Inside the for loop I have taken only, I am printing only one value, that is n into I. Next, so this is the synchronized method which is there in the class table. Remember this part, this class table, and inside the class table I have print table which is synchronized method. After that I am creating two threads. See here it is not a thread. Why it is not a thread means this class is not declared, this class is not extending either thread class or not implementing with runnable interface. This is normal class, so it does not come under thread. So when we consider that class as thread is, if you see this class my thread one extend thread. So now because we are writing multi-threading programs now, that's why we have to take threads compulsory. In addition to the main thread, you have to declare at least one more thread. Means for writing multi-threading programs, we need minimum 2 threads. When main is always there, that is one thread. In addition to the main thread, we can write one more thread if you want to write multi-threading programs. So how do we define or create a thread is, this is the syntax. Already so many times I explained this one. How do we define a thread? Class myThread1 extends thread, or here we can write implements runnable. Both are correct. Okay. Now next, so already I have taken one class table. Inside that only I have written print table method now. Now how do we access the synchronized print table method of table class is by creating object for table class. With that object I can access the print table method of this class table. So for that what I am doing is I want to create an object for table class. This is the procedure. Now class myThread1 extends thread means this is one thread. Table T means it is an instance reference variable. Next myThread1 it is a constructor. Last class I explained everything. In place of table there it is display. Same concept I am taking. So table T myThread1 table T this dot T is equal to T. Means I am assigning this T to our T. This T means first I will send table class object to this reference variable T. Means after that object is assigned to this T. Okay. Next we are writing the overriding run method. Compulsory we will write overriding method now. If whenever you create a thread, so inside the overriding run method only we will write the functionality of this thread. So here this is overriding run method. Inside the overriding run method I am invoking the print table method of the table class. Already I created object or I assigned object to table class reference variable through this constructor. Okay, the main purpose of this constructor is we are assigning the object, okay, which we got here. That object is assigned to this reference variable. Means table T is equal to new table. Actually you have to write now. That new table I am sending to this one, and that reference, that address is assigned to this. Means one object is created using this constructor for table class. With that object I can access the print table, which is the synchronized method of table class. So already object is created for table class. So inside the overriding run method what I am doing is I am invoking the print table method. Print table method is taking one parameter now. See here, print table method is one integer, taking one integer parameter. What I am doing is I am invoking print table method with the argument 5. So T dot print table 5 means it will go to this one int 5. Okay. Now what will happen? N is holding 5. So for int I is equal to 1 means first I is equal to 1 means 5 into 1 it will print. Next when I is equal to 2, 5 into 2. Next I is equal to 3, 5 into 3. Like that this 5 table. 5 into 1, 5 into 2, 5 into 3, 5 into 4, 5 into 5. Up to 5 into 5 I am printing the values for 5 table. Okay. This is like that. That's why here it is print table. This is 5 table. Now inside the overriding run method I am invoking the print table method with the value 5. Next, so here this is one thread, no? You know this is one thread. Like that I am creating one more thread. Already explained, no? Any number of threads you can create, but change the name. That's it. Next, class myThread2. Previous class name is myThread1. So this is one thread for me. In addition to the main thread, this is one thread, and I am also creating one more thread with the name myThread2. So any class which extends thread means it is a separate thread. So in this program, if you see, we have 3 threads. They are main thread, see, main thread and myThread1 and myThread2. So here we have 3 threads. Okay. Now this is the second thread. Now class myThread2 extends thread. Okay. Now same, nothing is there. But here inside the overriding run method, we will write the functionality of this thread now. So here what I am writing is T dot print table of 100. In the previous one what I have written, T dot print table of 5. Here only I am changing this value, except this everything is same. Like that you can create 10 threads. Again take class myThread3 extend thread. Next class myThread4 extends thread. Like that we can create any number of threads by write the same code, only change this value. Okay. In the first thread I have taken 5 no. Now it is 100 now. If you want to take third thread, take your own value 10. Okay, like that we can, by changing this value we can create any number of threads, but the thread, this class name must be different. Okay, this is same. So here I have created 2 threads, like myThread1 to invoke the print table method with the value 5, and myThread2 another thread to invoke the print table method, which is a synchronized method with the value 100. Okay, so here if you understand up to this we will repeat the same thing in the next program also. So this is class table. Inside that I have written synchronized print table method. After that I have created one thread, and I am invoking inside the overriding method, I am invoking print table method with the value 5. Next I am creating one more thread, and inside the run method I am invoking the print table method with 100. Okay, now take one more class. So public class, this is the synchronized example. Public static void main, this is one thread. Now compulsory we have to take one more class to write the main method, and main is also called thread. Next, so in which class we have print table method, which is synchronized method? In table class, no? In table class we have one synchronized method, that is print table. So that's why I have created an object for table class. That's why table OB1 is equal to new table. Okay, object is created here for table class. So by creating object for table class only, we can access the print table method of that class. And that's why I have created object for table class. After that I am creating 2 threads objects. Okay, so myThread1 T1 is equal to new myThread1 of this new table. OB1 is holding the address of this object table now. So the address of the table object is stored in OB1. So I am sending that address as argument to this constructor. So this constructor means I am sending the object address. So through this constructor means T holds the address of the object. Means here also this dot T means this is holding the address of this object. That's why first I have created table class object like this. After that I am sending this address of this object to the constructor using myThread1 of OB1. Similarly, only one object we have to create to understand synchronization concept. Next I am creating one more thread class object, and I am sending the same object, okay, to this constructor. After that T1 dot start, T2 dot start. First T1 dot start means our thread is registered with the thread scheduler. Okay, next now here we have 3 threads, main thread, T1 and T2. Next after that T1 dot start means what will happen? First start method of the thread class will be executed. So as part of start method of the thread class, this overriding run method will be executed. You know, inside the start method of the thread class, run method has to be invoked. No? But here I have written run method, overriding run method. That's why as part of start method of the thread class, this will be executed. So T dot print table of 5 means it will go to this one. Means first thread. What is the first thread here? This first thread got the lock of this object. Okay. Once it got the lock of this table class object, until the completion of this synchronized method, okay, no other thread can access the synchronized method. Means here we have 3 threads now. Main thread T1, T2. Okay, but inside T1 and T2 only we have written, we are accessing print table method. This is print table of 5. This is print table of 10. Suppose if you want to access inside the main thread also, Here also write printed table of 10. This is the functionality of thread. Now after this statement, if you write printed table of 100, the 10, that is the functionality of main thread. But try to understand, here I have created only one object. Okay. Here I have created only one object. But but here this thread is, when this thread is, that is, this is first T1 dot start we have written. So when this thread is accessing the print table, which is synchronized method of this table class, then the second thread cannot access the same synchronized method. Means the first thread got the lock of that object. Means all the synchronized methods of this class table are locked. That's why first which thread completes its execution, this synchronized method means first thread. That's why first you will get the output as 5 into 1, 5, 5 into 2, 10. Like that you will get the values 5, 10, 15, 20, 25. Means the first thread completes its execution. After completion of this synchronized method execution by the first thread, then it releases the lock of this table class object. Then once it releases, then what is the other thread which is waiting for the same method? T2. So inside T2 dot start means inside the second thread also we have written T dot print table of 100. So in this case, first thread completes its execution of that synchronized method and it will print the values 5, 10, 15, 20, 25. Then T2 dot start means again as part of start method it will invoke the overriding run method and it will invoke the print table method with 100. Next the output is 5, 10, 15, 20, 25 followed by 100, 200, 300, 400, 500. So this is the output. So here you can understand the synchronized concept. You will get the regular output. Means only one output you will get. Okay, because first thread got the lock of the table class object, means first it will execute the synchronized method completely. The first thread will execute the synchronized method completely. After that only the second thread got the lock of that table class object and it will complete the synchronized print table method. That's why the output for this program is 5, 10, 15, 20, 25, 100, 200, 300, 400, 500. That's it. Next, in the same way, you can understand synchronized block. What is the difference between synchronized method and synchronized block means? See, suppose if you take synchronized method, print table method, here if you write 100 lines of code inside the print table, which is synchronized method. So inside the synchronized print table method, if you write 100 lines of code, then if that thread has that, if first thread is accessing this synchronized print table method, until the completion of this synchronized method by that first thread, the remaining threads cannot access. Means the remaining threads have to wait now. Means waiting time of the remaining threads is increased now. But here I want only few lines of code which should be locked. I don't want to lock all the 100 lines of code inside this print table or inside this synchronized print table method. Then in that case, go for synchronized block. Okay, synchronized block can be used to perform synchronization on any specific resource of the method. Suppose if you have 50 lines of code in your method, but you want to synchronize only 5 lines, then why should we use synchronized method? If you want to synchronize all the 50 lines of code of that method, then declare that method as synchronized. But if you want to synchronize only 5 lines out of 50 lines, then don't declare that method as synchronized. If you declare the method as synchronized, means all the 50 lines are locked. Means the other other threads have to wait now until the completion of these 50 lines. But I need only 5 lines to synchronize. Then in this case, go for synchronized block. So in this case, no need to synchronize the entire method. Only we will take some part of that method and we will synchronize that. Okay, we will synchronize that block. So here is the same program I have taken, so you can easily understand class table. So here I have not declared this method print table as synchronized. See understand the difference between the last class and the last program and this program. See here, this is the program on synchronized block. That's why don't declare the print table method as synchronized. Here I want to declare only some part. Only I want to print. I want to synchronize this for loop only. Okay, that's why how do we write the syntax is synchronized of this. This means current class object. So synchronized of this. After that, I want to synchronize only this for loop. What does it mean? Means before this synchronized block, you can write any number of statements, and after synchronized block also we can write any number of statements. But these statements and these statements will not be synchronized. Okay, means will not be blocked. Only this part is synchronized. Means this is nothing but synchronized block. So whenever a thread will enter into this, will execute this, okay, this code, only it has to complete the entire code of this synchronized block. Okay, but if it is non-synchronized, means before this we can write any number of non-synchronized lines. No? After that also we can write any number of statements. No? But there is no guarantee to execute these statements completely, or there is no guarantee to execute these statements completely. But once the thread executes this method print table, this part must be completed. Why? Because this part is declared, or this block is called synchronized block. Means this part is locked. Means the one after execution of this synchronized block completely, then only it can execute then only the other thread can enter and execute this synchronized block. Same like synchronized method, it is synchronized block. Synchronized means once thread, whether it is block or method, once a thread starts executing that synchronized method or block, after completion of the entire code of that synchronized block or method, then only the other thread can access that synchronized method or block. That's why completely it has to, this part is to be executed once you declare this block as synchronized block. Okay. Now the remaining program same only. Same as previous program. Okay. Now only thing is you have to remember, I have kept this for loop, okay, inside the synchronized block. In the previous program I have taken synchronized method, in that I have written for loop. But here this is non-synchronized method. So inside non-synchronized method I am writing synchronized block. Only few lines of code I want to make as synchronized. Okay, same program. Next, last one, static synchronization. This is also very easy. Static means class level. If you take anywhere static variables means class level variables. Like that, static synchronization means class level lock. Here previously we have taken object level lock. No? Means object is locked. Once a thread is accessing the synchronized method of that object, this is first that thread has to get the lock of the object. But here class level object means, so here you can understand, I have given one example also, you can understand this one. After that I will show you the difference in the program, then you can easily understand. Static synchronization means class level lock, not object level lock. Static is there. Okay. Now class table, see here synchronized, here one more thing I have added. Static, same program I am taking. So class table is the class name. Inside that I have written synchronized print table only, like in the previous programs, first program. But what I am adding is here, I am declaring this print table as static also with static keyword. That's why this is called static synchronized method. Okay. means concept is static synchronization. So if a method is declared with both the keywords synchronized and static, then that method is called static synchronized method. Previous first program, that is only synchronized printable method now, but here it is synchronized as well as static. So this is called static synchronized printable method. Understand the difference? Synchronized as well as static. Now only one difference I will explain. You can remaining program you can understand on your own. Same for loop I have taken up to 10. Next same n into I. We are printing the values of any table by giving the value to this n. 5 table or 10 table or 100 table, 1000 table, 2 table like that. Okay. Now synchronized static void print table. Remember this one. Everything is same. Next, here I have taken one thread. See how many threads I am taking. My thread 1 is 1. My thread 2 is another thread. And my thread 3 is another thread. My thread 4 is another thread. Here I am creating 4 threads explicitly. In addition to these 4 threads, we have main thread is there. That's why in this program, you can understand, you can see 5 threads. So it is a multi-threaded program. If one program is given to you, you should be able to say whether it is a single-threaded program or multi-threaded program. If only one main thread is there, then that program is single-threaded program. Now here this is one thread for me because this class extends thread. When a class extends thread means it is a thread. Means this is the definition of thread. Or like this we are creating a new thread. So this is the creation of the new thread. How do we create a new thread in multi-threading is using this syntax. Any class which extends thread or which implements runnable means that is a new thread. So class my thread 1 extends thread. Inside that I have to write compulsory overriding run method no, to write the functionality of the thread. So inside the overriding run method, I am writing the functionality of the first thread. That is for my thread 1. If you see inside the overriding run method of this my thread 1 class, what I have written, table dot print table of 1. Now you can understand. Previously it is object dot no t dot print table, but here it is table dot. Table is the class name. So already explained. So inside the class table, say understand carefully, easy only this program. So this is the class table. Inside the class table, I have synchronized static print table method. So how do I access synchronized static print table method of table class is using class name. That's why this is called class level lock. So table dot print table of 1 means I am invoking the print table method with the value 1. Means it will print 1 into 1, 1 into 2, 1 into 3, 1 into 4 like that up to 1 into 10. Same concept I am using print table method only. But previously if you see in the first program and in the second program it is t dot. Whether it is synchronized method or synchronized block, we are using t dot print table because already explained for synchronized method and synchronized block we need object lock, but whereas in static synchronization we need class lock. Means the thread requires, see again I am repeating, the thread requires, okay, the thread requires the object lock in case of synchronized method and synchronized block. But in case of static synchronization, the thread requires class lock of the entire class. Means all the objects of that class are locked. Difference between class lock and object lock is, once you define the class, we can create any number of objects. Okay, already you know this one. Once you define the class, we can create any number of objects. Okay, in case of static, in case of synchronized method, or synchronized block, we need only object lock. Suppose if you create 10 objects for a class, if you want to lock only the first object, means if one thread is accessing the synchronized method of the first object, then that thread needs only the lock of that first object. It does not require the locks of the remaining objects. That's why that is object lock. Even though you are having 10 objects, but if one thread wants only one particular object lock to execute the synchronized method of that object, then it requires only the lock of that object only. Why it requires the locks of the remaining objects? Not necessary, no? That's why understand the difference between object lock and class lock. Object lock means, okay, we have 10 objects for a particular class, but if a thread wants to lock only one object out of the 10 objects, only that object is locked, whereas the remaining 9 objects are unlocked, no? They are free. But in case of class lock, once the thread got the lock of that class, means all the objects are locked. That's it. That is the difference between object lock and class lock. So here understand, I have created 10 objects for a particular class. Okay, now with respect to these 10 objects, I will explain the difference between object lock and class lock. So in case of object lock, if one thread is locked by, not one thread, if one object is locked by one thread, means the remaining objects are unlocked. They are open to access. Only one object is locked by one thread, means the remaining 9 objects are unlocked. Any number of threads can access the remaining 9 objects. That is object lock. But class lock means, here also we have 10 objects. But if you see the class lock, or a thread got the lock of the class, then all the 10 objects of that class are locked. Means the other threads cannot access the remaining objects also. Whereas in the object lock, only one object is locked by one thread. Means remaining objects can be accessed by any number of threads. No? There is no problem in that. Only one object is locked by one thread. The remaining objects are open. But if you take class lock, all the 10 objects are locked. Okay? So if this is like your, if you lock the main door. If you lock the main door, means that is class lock. Means all the rooms of your house are locked. No, if you lock the main door, that is called class lock. But if you lock only bedroom, that is object lock. If you have 5 bedrooms in your house, okay, so if you lock the main door, means that is class lock. Main door locking is nothing but class lock. If you lock the main door, all the 5 bedrooms are locked. No? So I think each and every bedroom is one object. So all the 5 objects, means all the 5 bedrooms are locked once you lock the main door. That is class lock. Locking the main door of the house is nothing but class lock. But I don't want to lock the entire house. Means I don't want to lock the 5 bedrooms. I want to lock only one bedroom. In that case, what I will do? I will lock only that particular bedroom. No? That bedroom is nothing but one object. Even though you have 5 objects, means 5 bedrooms, but I am locking only one bedroom is nothing but locking one object. Locking the main door is nothing but class object. If you got the lock of the class, means all the objects are locked. If you understand this difference, then you can easily follow this program. This is static synchronization, means it is like class lock. No, we are locking all the objects of that particular class using static synchronized. Okay. Now here I have given one more example also. First try to understand this example. After that you go for class lock. So here how do we access the print table of method of table class name dot print table. Why it is class name means here it is this method is declared with synchronized and static. That's why class name dot printable. Next one, in the second thread I am invoking with different value 10. Same again, class name table dot means class name. Third thread also with different value I am invoking. Okay, with the class name only. Fourth thread also same. So next I have created objects for 4 threads separately. After that I am invoking the start method of the thread class on each and every thread. That's why t1 dot t2 dot run. So t1 dot start means so first t1 means first thread. No, this is the this first well, we are invoking table dot print table means first thread. Whenever you write here t dot start or t1 dot start, the first thread got the class level lock, means this entire class is locked, means all the objects of this class are locked. Means here what I am doing, I am invoking print table method which is synchronized and static with the value 1 using class name. This is nothing but that first thread got the lock of the entire class, means all the objects of that table class are locked. Now I am invoking the print table lock 1 means first here it will print the 1 table up to 10, 1 into 1, 1 into 2, 1 into 3 up to 1 into 10. So next after that whenever you invoke t2 dot start means where is the thread to, this is which value I am taking 10. Next first 1 into 1, 1 into 2, after that 10 table, 10 into 1, 10 into 2, 10 into 10, 10 into 10 last. Next after that with the t3 dot start, what will happen? The run method of the thread 3 will be invoked. That's why with the value 100. Next you will get 100 table up to 10. Next t4 dot start. T4 means this is T4 is my thread 4, no? That's why with this is 1000 table. Like that here, because of static synchronization, we have to use, because of static synchronization, we have to, 2 important points only I will explain here. Because of static synchronization, you have to use class name dot synchronized method name. This is synchronized method which is declared with static. That's why class name dot print table. Next here I am creating 4 threads. So t1 dot start means until the completion of the first thread, until the completion of that synchronized print table method by the first thread, the remaining 3 threads cannot access. They have to wait until the completion of the static synchronized print table method by the first thread. Okay, that's why your output will be first 1 table. Next this thread got the lock of the entire class. Then what is the second thread? Next 10 table you will get. Next output is t3 dot start. Then the 100 table. Next is t4 dot start 1000 table. Like that you will get the output. So with this the mutually exclusive concept, that is 3 types of mutually exclusive is are completed. 3 concepts I have completed till now. Okay. Here there are 2 types of thread synchronization: mutual exclusive and inter-thread communication. So under mutual exclusive, we have synchronized method, synchronized block, and static synchronization. For these 2 concepts, we need object level lock. For this concept, we need class level lock. So at least try to remember 1 program on each of these 3 concepts. So with these 3 concepts, this mutually exclusive is completed. Okay. Next we will see inter-thread communication. So next week and again I will get to 2 classes now. In 1 class I will explain inter-thread communication. In tomorrow's class we will revise either second unit or third unit. Okay, important concepts I will revise in the tomorrow's class.